Alright, so today we gotta look at special right triangles. So far, we've solved with Pythagorean theorem. That's really it. Today we're gonna look at two kinds of triangles that are special. 45, 45, 90, 30, 60, 90. What's special about them is that they have a pattern to them. So if you memorize the pattern, you can solve, if I give you one side length, you can solve for all three sides without doing Pythagorean theorem. It's kind of like a Pythagorean triple in that it ends up being like a shortcut. But for now, I want you to see, there's only two of them, but it takes a minute because it's kind of like abstract. So the first one is 45, 45, 90. So in a 45, 45, 90 triangle, so if I give you a right triangle and I put two 45-degree angles in there, there's actually a pattern to the side lengths. The hypotenuse is the square root of 2 times as long as each leg. So here's, instead of using x, we're going to use a. So the two legs are a lengths long. Then the hypotenuse is a length times the square root of 2. You don't actually have to multiply the square root of 2. You can just leave it. So this is, you can kind of think about it as 1, 1, root 2. Because if, like, the two legs were both 1, and I did Pythagorean theorem, think 1 squared plus 1 squared would equal the hypotenuse, right? Well, what's 1 squared? 1. So 1 plus 1 is the hypotenuse squared. What's 1 plus 1? Is the hypotenuse squared, and then our last step is usually the square root. So you see where the square root of 2 comes in? So that's kind of how the pattern is created. If these are both the same length, because in a 45, 45, 90 triangle, the two legs are always the same length. It's like a isosceles triangle. So you can kind of think about either memorize the pattern, a root 2, or think the hypotenuse is the leg times the square root of 2. So notice on example 1, I either give you a 45-degree angle, or the picture will be, this is an isosceles triangle. When you see the isosceles triangle, think 45, 45, 90. So, I don't know what it was. So you can set up the pattern. Everybody kind of does this a little bit differently. I like to write out the pattern. So this is a 45, 45, 90 triangle. So these are the two legs. So this is a root 2. So I can find the missing side lengths. This side is going to be the same as the bottom. So this is 12 centimeters. This hypotenuse, I should do it in a different color. The hypotenuse is 12 square root of 2 centimeters. And you just leave it like that. That's it. Some people like to think, okay, the hypotenuse is the leg times the square root of 2. I know the length of the leg, it's 12. So my hypotenuse is 12 square root 2, because I substituted the 12 for the leg. Every year I kind of teach it a little bit differently. One year I made everybody write this out. Some people can do the pattern. It's kind of up to you how you want to remember these triangles. Now I'm not always going to give you just the leg. This is the easiest kind of this triangle. If I give you a leg. Here, which side did I give you? This is the hypotenuse. So this is a square root 2. These two sides are both a. And the reason I use a and not x is because, like, on your homework it'll say solve for x and y, and I don't want you to get confused. Very rarely do we use a. So if I'm trying to find these two side lengths, what do you think it is? Just 6. Almost like the square root of square roots of 2 cancel out. So this side is 6, this side is 6. And I know it's a 45, 45, 90 triangle because of that 45 degrees. Okay, so we're going to keep going. It gets harder as we go through this. That wasn't too bad though, right? C is the hardest in the 45, 45, 90 triangle. So C, this is the hypotenuse. So this is equal to a square root of 2. And we got to find a. So I'm going to do some work at the bottom. We got to remember, there's a reason why we did the radical review on Monday. Because I have 10 equals a times the square root of 2. And I have to solve for a. Because I can't just cancel like I did over here. So I have to solve for a. So what do you think I should do? Yeah. Divide each side by a? Or divide each side by square root of 2? Right? If you had 10 equal 2a, what would you do to both sides? I would divide by 2, right? And then 2 learn that in algebra. It's the same concept, we're just adding a square root on it. So I'm going to divide both sides by the square root of 2. So I get my a value as 10 over the square root of 2. What's wrong with that we learned on Monday? You can't have a radical at the bottom. So I have to rationalize. So now I'm going to multiply by the square root of 2 over the square root of 2. And what does that turn into? The top becomes 10 root 2. What does the bottom become? Can I simplify that even further? Aren't these divisible? So a is actually 5 root 2. So both legs are 5 square root of 2. When we do these special right triangles, none of your answers are to be decimals. They're either whole numbers or there'll be a square root. Does that kind of make sense? You end up seeing that this kind of situation where you have a number here, like a regular number as the hypotenuse, there's actually a pattern. And if you remember that, then you don't even have to do all this. So let's try with 12. Okay, 12 is my hypotenuse. So I know 12 has to equal a times the square root of 2. You're solving for a because you're solving for the legs. So what was our next step? What did we? Yeah, I divided by root 2. And you'll get a is 12 divided by root 2. But again, I have to rationalize. So times root 2 over root 2. And you get a is 12 root 2 over 2. But can I simplify? So a is what? 6 root 2. Do you kind of see what happened with these two numbers compared to this? Do you see how really if you have a whole number as the hypotenuse, you can really just cut it in half and add square root of 2. 10, this was 5 root 2. 12, this was 6 root 2. Or you can go through the process. It's completely up to you. Because if I had like an 11, it would be like 5.5 square root of 2. So that's 45, 45, 90. That one's not too bad because you only have to deal with legs and a hypotenuse. And you just need to remember this. That the hypotenuse is the leg times the square root of 2. Or remember the pattern. Okay, tomorrow we'll go through and we'll write out what do we need to know for the quiz. I usually write both of these down because it depends on how you want to remember it. Questions? Okay, the other one is a 30, 60, 90 triangle. This one's a little bit trickier because there's 3 different kinds of sides. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So the ratio here is 1 to square root of 3. Because if I put these two together in Pythagorean theorem, 1 squared, square root of 3 squared gives me the hypotenuse squared. What's 1 squared? What's the square root of 3 squared? And then what's 1 plus 3? So now do you see if I square root, I get the hypotenuse is 2. So again, that's just how the pattern's created. Somebody a long time ago figured out this pattern. So here, let's do a, 2a, and a square root 3. So the problem is you have to realize what's the shorter leg, what's the longer leg. Obviously in some pictures it'll be obvious. This is the short leg, this is the long leg. This is always the hypotenuse. If it's not obvious, I always think the shorter leg is across from the shortest angle, the smallest angle. So the shorter leg is across from the 30 degrees. The longer leg is always across from the bigger angle, which is the 60 degrees. And then the hypotenuse is always across the 90 degree angle. So there's 2 things you have to remember. That the hypotenuse is 2 times the short leg, and the longer leg is the shorter leg times the square root of 3. So you can either remember those 2 sentences, or you can remember the pattern. So like a 45, 45, 90 triangle shows up a lot because it'd be like cutting a square in half. 30, 60, 90 shows up a lot because it would be like cutting a rectangle in half. Okay, so these show up a lot throughout the rest of the semester. But it's kind of like a shortcut. And if you look in every problem, like I said, I only have to give you 1 side length, and you can find all 3. So let's look at example 2. So for A, do we think 2 is the short leg, the long leg, or the hypotenuse? This is the short leg. So this is A. The leg down here, this is the long leg. So remember that's A square root of 3. And then this one's here is the hypotenuse. So this is 2A. So there's really not a whole lot of work for you to show for these problems. This is my work. When you get better at it, you don't even have to show this. I can just do it in my head. So if A is 2, if my short leg is 2, what's my long leg? Just 2 root 3. And you don't actually have to multiply. What's my hypotenuse? What's 2 times 2? 4? Because it's twice as big. There you go, you're done. And you know it's a 30, 60, 90 because of the 30 degree angle. Okay, that's the easy one. B is a little bit harder. The side length that they give me, is that the short leg or the long leg? Long. It's across from the 60 degree angle. So this is the long leg. This is A square root of 3. This side here, this is the short leg. So it should just be A. This is my hypotenuse. This should be 2a. So in this situation, what do you think A is? What do you think the short leg is? 5, because I can just cancel the square root of 3's. So this side is 5. Let me use this pen. And then what's my hypotenuse? 10? Yeah, you're right. Because it's 2 times 5. Alright, let's try the last one. This one is by far the hardest that you get in this whole section. 10 is which leg? Short or long? This is the long leg. So this is a square root 3. This side here is the short, so it's a. This is the hypotenuse, so it's 2a. This problem is similar to this problem because we have a whole number, 10, but it's supposed to be equal to some number times the square root of 3. So I'm going to kind of set it up the same way. I have to make 10 equal to a square root of 3, and I got to solve for a. So what did we do in the last one when we were trying to solve? I divided by root 2. Here I'm going to divide by root 3. So square root of 3, square root of 3. So I could just say, okay, a is 10 divided by the square root of 3. But what did we learn Monday that we can't do? Yeah, we can't have radicals in that bottom. So now I got to rationalize. So I'm going to multiply by the square root of 3 over the square root of 3. What does the top become? 10 root 3. What does the bottom become? Now, is 10 divisible by 3? No, so this is my final answer. It's ugly looking, but it's not a decimal. So the short side here is 10 root 3 over 3. Okay, now the thing that will trip most people up is how do I multiply that by 2 to get the hypotenuse? Which of our 3 numbers is going to get multiplied by 2? The only one that gets multiplied by 2 is the 10. If I do 10 root 3 over 3 and I times that by 2, the only number that gets multiplied by 2 is 10. Think 2 over 1. Think 2 over 1. A lot of people will multiply the denominator also. You don't want to do that. Think 2 over 1. So this final answer is 20 root 3 over 3. Like I said, this is the one that's the worst. Questions so far? Okay, so why do we have to use these? Because sometimes we have story problems that are more, it's more helpful to use these 2 shortcuts. These are only 2 special right triangles. That's it. Just these 2. So you're making a guitar pick that resembles an equilateral triangle. So all 3 sides here are the same. They're all 32 millimeters. It's real bad I got going on. What is the approximate height of the guitar pick? So you want to find the height. We could do what we did Tuesday and do Pythagorean theorem. Or I could use my special right triangles to find the height. Because in an equilateral triangle, all the sides are the same. Aaron, do you have a question? Times it by what? Why am I timesing it by 30? Got it. I think you're thinking what I'm thinking. What are all the angle measures here? If all the sides are the same, what are all the angles? All the angles have to be the same too. They all got to add to 180. They all got to be the same. Yeah. Oh, you can't see what I'm doing. They all have to be 60. So all of these angles are 60 degrees. So if I cut my guitar pick in half, I end up with, here's my right angle, a 60-degree angle at the bottom. The angle at the top is 30 degrees because it's 60, we've cut it now in half. This side here, the 32 millimeters, that's my what? This is my hypotenuse. This 32 is going to get cut in half. So it's 16 millimeters, and that's what leg? The short leg or the long leg? This is the short. I'm trying to find H, which is the long leg. I don't know why it keeps doing that. So if I use my 30, 60, 90 triangle pattern, this is A, this is 2A, this is A square root 3. So what do you think H is? Just 16 root 3 millimeters. So I can do, I can skip Pythagorean theorem. But it really only works when it's equilateral or triangle. Because the hypotenuse and the short side have to be double. The ones we did on Tuesday wasn't a equilateral triangle. I'm trying to find it. This was isosceles. So the angles aren't 60, 60, 60. But if it's equilateral, you can do this instead of Pythagorean theorem. We'll get to this a lot when we do chapter 10, when we talk about 3D shapes. Because you'll have like prisms and stuff. Okay, last one. Ready? Okay, a car is turned off while the windshield wipers are moving. The 24-inch wipers stop, making a 60-degree angle with the bottom of the windshield. How far from the bottom of the windshield are the ends of the wipers? Okay, so this is a hard picture to draw for me. Here's my car. Windshield wipers stop, and they make a 60-degree angle. This probably should be a bigger angle. So they stop and make a 60-degree angle, and it's a 24-inch wiper with the bottom of the windshield. How far from the bottom of the windshield are the ends of the wipers? So we're trying to figure out this side. That's my right angle. So what do you think? Let's try. So we got a 30, 60, 90 triangle. So we need hypotenuse, short, and long. So 24 you think is this is the hypotenuse. So remember that's 2A. What we're trying to find, here's the tricky part. Do you think that's the short side or the long side? It's across from the 60-degree angle, so this is the long side. Does that make sense? So it's A square root 3. This thing that we don't care about down here is the short side. That's why I changed the way the diagram looked, because otherwise it ends up looking where this side that we're trying to find is shorter. But remember, the long is always across from the bigger angle. This is going to be my 30-degree angle, so the short's always across from it. So what do we think the long side is? How big? If this is 24 and it's 2 times some number, what's our short side going to be? 12, which makes this side, yeah, so this is 12 root 3 inches from the bottom of the windshield. question.